Hi everyone. Welcome to lesson 12. We are continuing our work with solving using trig, but this time instead of finding the sides, we're going to be finding the angles. As you can see, my setup for notes is a little differently, but hopefully it goes just as well. And we have a calculator, the Desmo scientific calculator, right here on the right side that we're going to use. So let's get started. First off, we are going to remind ourselves about our three basic trig functions. So I'm going to put my given angle right down here. So we have opposite, adjacent, and the hypotenuse. So our three basic trig functions are sine theta is equal to opposite over hypotenuse. We have cosine theta is equal to adjacent. Oh, if I can spell adjacent correctly. Let me just erase that. There we go. Adjacent over hypotenuse. And then we have tangent theta, which is equal to opposite over adjacent. Now, in lesson 11, we solved for one of the three sides. But here, we're going to be solving for the angle. So you really need to be aware of your calculator and the steps we're going to take to solve. So find a missing side angle. To find a missing angle, we're going to set up the ratio using one of the three basic trig functions. Then we will be using what is called the inverse function of the selected. This is not the reciprocal. This is not cosecant, secant, and cotangent. We're literally going to be using inverse of sine, cosine, and tangent. So think of it like this. So sine theta is equal to opposite over hypotenuse. But to find the angle, we're going to do sine inverse, and inverse is denoted by -1 of opposite over hypotenuse is equal to theta. And we're going to do this for all three trig functions. So we're going to have inverse of cosine adjacent over hypotenuse is equal to theta, and inverse tangent of opposite over adjacent is equal to theta. So you need to know where to find these inverse functions on a calculator. If we come over here to the Desmos calculator, I'm actually going to make this a bit smaller so I can bring it up here so it's easier to see. All right, so as you can see here on the Desmos, we have sine, cosine, and tangent. Those do not have the inverse. What you need to click is the function button, and now you can see sine inverse, cosine inverse, tangent inverse. On regular calculators, on normal like TI calculators, let's go and find an image of that. This guy right here. You're going to have to hit the second button and then one of the three trig functions. You'll see the inverse ones right above the sine, cosine, tangent buttons. You just have to hit the second button. So there's that. All right, so let's get to our examples. So we're going to do the same thing we did with finding sines. I highlight my given angle. So it's right there. And then I label the two sides that they give me. They give me opposite and they give me hypotenuse. So that tells me we are going to use sine. So sine theta is equal to 4/7. Now, don't do any decimal shenanigans here. All we're going to do now is inverse sign of the fraction is equal to theta. So 4/7 goes with the inverse, and theta is now what it's equal to. And this will have us solve for theta. So once we're at this point here, we come over here to our calculator, sine inverse, and then 4/7. I'm going to close parentheses. Oh, it closed the parentheses for us. And then hit enter, and there we go. So that is our angle. And as you can see, my calculator is in degree mode, which it should be. Now, when we are rounding for angles, we are always going to round to the nearest whole degree. So our calculator says 34.84. So our angle, we're going to round up to 35 degrees. And there you have it. We have solved for an angle. All right, our next one. Here is my given angle. We have opposite, we have adjacent. So we're going to be using tangent. So tangent theta is equal to 14/8. Again, don't even worry about simplifying the fraction. Just leave it alone. Do tangent inverse of 14/8 is equal to theta. And now it is calculator work. So function tangent of 14/8. Enter. There we go. And we get 60.2, but we round to 60 degrees. Some students actually find finding the angle easier than finding a side. All right, next we have to set up the right triangle. And so that's what we're going to do here. Make sure I got my colors all right. So when we are setting up our own right triangle, remember, capital letter C is always the right angle, and then A and B can go in either place. We want to find angle A, so that's where I'm going to put my theta. Then lowercase b, which is opposite angle B, is 8. And then lowercase c, which is opposite angle C, is 10. So we have an adjacent and a hypotenuse. So adjacent hypotenuse is cosine. So cosine of theta is equal to 8/10. Again, don't worry about simplifying the fraction. We're going to put it into cosine inverse. 8/10 is equal to theta. And now we're going to go to our calculator. Cosine inverse, 8/10. 36.8. We round up to the nearest degree, so 37 degrees. All right, another one. Set up our triangle. I'm going to set it up exactly like we just had it. A, B, C. But this time, angle B is what we're trying to find. So I'm going to put my theta at angle B. A is 12. Remember, little a is across from angle A. And B is across from angle B. So we have an opposite side and an adjacent side. So opposite adjacent is tangent. So tangent theta is equal to 7/12. Inverse tangent of 7/12 is equal to theta. And theta is equal to, come over here to our calculator, 7/12, 30.2. So theta is equal to 30 degrees. And there you have it. Basic solving for an angle. Now, that's not all we're going to do with solving for an angle. Yes, we're still working with angles of elevation and depression. So a quick reminder, the angle of elevation is when you're measuring the angle from the floor or the ground, and the angle of depression is when you are measuring from a ceiling or a height. Again, think of angle of elevation as looking up, and if you are looking up and have an angle of elevation, the right triangle I want you to use looks like this with the angle down in the bottom. Angle of depression is looking down like an upside down right triangle with the angle up top. So let's now get to our problems. All right, Maggie is needing to paint her house. She uses a 10-foot ladder and sets it against her house 14 feet up. So what is the angle that the ladder makes with the ground? So since we're making an angle with the ground, that is elevation. Oops, this is very not straight, but that's okay. Here's my right angle. All right, the ladder is the diagonal. 10 feet. And actually, the hypotenuse cannot be shorter than a leg, so we're going to adjust this from 14 feet down to 8 feet. So the house is vertical up and down, so we're going to put that as 8. And we want to know what the angle is that makes with the ground. So this is this angle down here. So we have an opposite and a hypotenuse. So sine uses opposite hypotenuse. So sine theta is equal to 8 over 10. Then we do inverse. So inverse of 8 over 10 is equal to theta. And we're going to round to the nearest whole. So sine inverse of 8 over 10. And we get 53.13. So the angle is 53 degrees. So there we go. Again, we had to fix this 14 here to an 8 because the hypotenuse is always the longest leg, so a leg cannot be longer than the hypotenuse. That was a mistake on my part. All right. So standing on a cliff 380 meters above the sea, Kent sees an approaching ship. If the ship is 240 meters from the base of the cliff, what angle is Kent looking down to see the ship? So it's an angle of depression problem. Ooh, that's a really bad side. Let me adjust. Oh, that's slightly better. Well, we're going to have to live with it. So over here is the cliff. It is 380 meters above the sea. So 380. And then the ship, which would be down here, is 240 meters from the base. So that's going to be our horizontal. Did I say 240? I meant 2400. And then we want the angle of depression. So we have an opposite side and we have an adjacent side. So we use tangent theta is equal to 380 divided by 2400. So tangent inverse of 380 over 2400 is equal to theta. And now calculator time. Inverse tangent, 380 divided by 2400. 8.997. So we're going to round that up to a lowly 9 degrees. So our angle of depression was 9 degrees. All right, last one. And then we're done with solving for angles. So a ramp is needed to allow vehicles to climb a 2-foot wall. The angle of elevation in order for the vehicles to safely go up must be 30 degrees or less, and the longest ramp available is 5 feet long. Can this ramp be safely used by a vehicle? So we just need to see if this angle right here, angle X, is going to be less than 30 degrees. So that's all we're checking here. What's nice, they give us a diagram. So we're checking this angle. We have opposite, we have hypotenuse. So opposite hypotenuse is sine. So sine of X is equal to 2 over 5. Sine inverse of 2 over 5 is equal to X. So now to our calculator, inverse sine of 2 over 5, and it is 24 degrees. So now we check, is 24 degrees less than 30 degrees? Question mark. And the answer is yes. So this ramp works. And there you have it, guys, solving for an angle. All right. And now that we're done with lessons 10, 11, and 12, we will be quizzing over these next week. All right. Have a great day, guys.